Given a binary search tree, find the lowest common ancestor of two given nodes in the BST. According to the definition of least common ancestor in Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Okay.
Yeah, and I just to add in, if there's any question you've seen before, just let me know and I can find another one.
Okay. So I've seen this one before. I've seen this question before. I mean, the idea is it's not that hard, where you traverse the tree and at each, so like for each node, you look left and right, and you kind of try to find if it's in the left subtree or in the right subtree, and you so it's kind of like a bottom-up approach, where like you output the last element, which has there's only going to be one, I guess, one element where like it's going to be in the left subtree and the right subtree, the P or Q.
Okay.
Yeah, if I'm not mistaken. So yeah, the function could return true if it's in the left in the left subtree or the right subtree, and you are interested in the case where it's both in the left and the right.
I see. Okay, so that's not quite the same. That's actually a harder problem than
okay.
this one. For this one, you actually have the or I guess to start off, what would be the solution, the runtime complexity for the solution that you gave?
Of n.
Right. So here, for this one, it's not just any binary tree. It's actually a binary search tree. So we can actually improve on that.
Okay, I see. So let me reread then, because yeah, it seems like I didn't understand it well enough. Because yeah, sometimes you see like a problem that you think you saw before, and you kind of like assume things right away. So let me see. Given a binary search tree, find the lowest common ancestor, or the lowest one. Okay. According to the definition of the lowest common ancestor is defined between two nodes as the lowest node in T that has both as descendants when we allow a node to be descendant of itself. Okay, so the lowest node. So in this case, it's actually so it's the lowest node, and it's a binary search tree. So that means that like if I'm given P and Q, let's say for a tree that's this one 6. So in the array that you gave me, is it the arrangement? Oh, sorry.
Okay, I guess just to think about what do we have guaranteed when we have a binary search tree that's different from a normally binary tree?
In the left subtree, we're gonna have the elements that are less than the current, and the right subtree you're gonna have greater.
Right. Yeah.
So here we'll have.
Right, I should just print out a full example.
Okay. All right. So P is 2, Q is 8, and the output is going to be 6. Okay. But so far I'm building the tree right.
Yeah.
Yeah. Okay. So 0, 4. Then here I would have 7 and 9. And null and
3 and 5 comes below the 4. Yeah.
Okay. 3 and 5. Okay, I see. So yeah, having 2 and 8, it's going to be 6, because that's the least common ancestor. Okay. Let's say it was 7 and 4. In that case, it would be still 6.
Let's say it's 7 and 9 that we're looking for now.
7 and 9, it would be 8, right?
Yeah.
Okay, I see.
So in your previous solution, the thing that you were saying is that you have the LCA when it turns out that the left and the right are in the respective subtrees,
Yeah,
right?
yeah, yeah. Yes.
Or you return left or you return right because otherwise you have a solution to those subtrees. So that
Yes.
solution still works here,
Yeah, it does.
but you can improve on it.
For sure,
Cool.
because now I can actually know where exactly to go and where the elements are going to be. Is
Right.
I can follow the kind of like binary search thing, where like I follow down the path and I maybe record the elements that I visited in both cases, or I could actually have them go at the same pace so that I know when it's going to diverge. So when it actually the paths diverge, that's when exactly I know like the least common ancestor, because that's when they diverge, the paths diverge. So for example, in the case of 7 and 9, it would be like 6. So 7 and 9, I go down like if, I have like a while loop that does iterations of like going which way I'm going for both the P and Q. So like they're both greater than 6, so I go 8. Then for 7, I will go left. For 9, I will go right. That means that I diverged at 8. That means that's the least common ancestor. Um, Let me see if that works for any case. So for 2 and 8, it should still work because I diverged right at 6.
Okay. So by diverge, I think because you were saying that you choose at each step. So by that you mean that you decide to only go down one branch.
Yes, exactly.
Got
So
it.
for P and Q, I will at each iteration I will decide either I go left for it for Q for P and Q, or I mean for P separately and Q separately, or I go
Yeah.
right for each of them.
Right.
And when they are not the same, they don't go the same paths. Like one goes left, one goes right. That's where I know the paths diverge, and that's exactly where the least common ancestor is.
Gotcha. Cool. Yeah, I guess that sounds good to me. What's the complexity for this?
Well, in this case, it's the worst case is still going to be O of n, because it could be like a very unbalanced tree where like you have all the elements to the right. But in the average case, it will be all of log of n.
Right.
Yeah.
Okay, cool. That sounds good to me. Let's go ahead and code this one out.
All right. Cool.
So I'll just move this to the top.
All right. Cool. So let me see. Let me delete this in the main function, and I will have public static LCA, and so I will be given like a node, right? If I
Yeah, you can just assume that it's the same where you're given the root and then P and Q,
okay, gotcha.
and then you can design your node in whatever way you want,
All right, cool,
as
got it.
long as it has just left right value, no parent.
Okay, so write that out. Two. The, the node. I have int down, node left and right. And then I have a public constructor takes in int. That. So I have. So I'll create 2 pointers. Node. P node or P current and Q current that at first are going to be at the root, and then what I'm going to do is while while P current is not equal to null, current to null, null to. So if if P if P is so yeah so these are going to be two pointers that are going to be going down a path. So if P so the idea is they should be the same until a point. So they're going to be different, only different at one point. They're going to diverge at one point, and after that, I don't really care. So actually,
Right.
it would be while P current is not equal to, while P current is equal to Q current. I might add additional, like we're for looking for nulls. So can there be, so like for example, I start at root, and then for one case it's going to be null. No, actually I don't think I have to worry. Well, I kind of do have to worry about, because they could be both null, and then I'm going to continue.
Okay.
So if P current is, while P current is equal to, and let's say P current is not equal to null. I don't think I have to do this one. It's going to be, but just
Yeah, it would be the same thing.
Yeah, I think so too. So if if P is greater than root, no, P current dot val, and P current is equal to root dot right, else P current is equal to root dot left, and then the same thing for Q. And then at the end, P current is not equal to Q current, return return root. Sorry. Yeah. Um, so I need to kind of, so I choose either right or left, but then I assign them, so I don't know what was the previous one. So let me see how I can,
Right.
yeah, so one way, and then I didn't use the correct here. Um, so let's see. What I could do
Right. So normally the thing that you were saying you would do is you just make a decision to go left and right, right, at each step.
Yes.
Um,
So
yeah.
yeah.
So
So
is there
okay.
any way you could do that? I guess the confusing part of yours is because it's at different steps of the iteration that you're referring to your left and right, right? Your P current and Q current. One of them, you know that you would return them immediately, but the other one you're returning at one level before, in a sense, right? Which is going to be the place that it diverges.
Yes. Wait. Can you say that again?
One of your items you're returning immediately as one of the candidates, but the other one you're returning at one level before, right? So if you had the case that, so there's a couple of cases, right? There's actually four things, but how some of them differ for the diverging is that for one of them it's in left and right, and then in the other one you're looking at the root at the node itself, right? And then you have your left or right item in one of the subtrees. But in both of them, it's the same thing with your code in that you're trying to return the one before.
Yes. Yeah, I do like try to return the one before. If they're not the same, like if so, like this check will just say that. So like in this code, I decide which way to go for P current, and this I decide for which way to go for Q current. And
Right.
if those choices diverge, then I return the previous. But of course, I could keep like a previous pointer or something like that.
Yeah, I think that is one of the options.
Yeah, well, that's one of the options, but I kind of think it's a little bit unclean. I don't know. That's why I'm trying to think of something else because, like, as I see it, like most of the time, or like not most of the time, but like I will go for both of them are going to be the same. When they try to choose not to be the same, I mean, when they diverge, kind of, that's when I right away return. So like, what I could do is probably I could maybe have actually only one current, and I what's it called? Change that current. I choose the path. I mean, I go down with that current as long as like Q and P try to go the same path.
Yeah.
But they try to go another. I just return that kind of like thing.
Right. Yeah, that
So
is another option.
I think that I like it more, really. 'Cause, so yeah, I like it more. It's more clean to me. Seems more clean. Uh, so I could just have like node Q Q uh, Q either Q direction and P direction.
Right. So one thing to actually make this simpler is P and Q are actually not integers, but they're also nodes,
Oh, okay.
which you can just do direct comparison to.
Mm. Okay. That's easier. Yeah. So in that case, I'll just use here val, and then if P dot value is greater than current dot value, then P direction is going to be kind of right. Otherwise, it's going to be left. Now, Q direction. And then if P direction Q direction are not the same, then return this current.
Okay.
The only thing is, of course, I have to, yeah. If Q don't know. And then in the end, I just or yeah, well, current. Yeah, I think that should work.
Okay, let's go ahead and run this on some test cases then.
Okay, so let's see. Node root is equal to new node 6. Root dot left is equal to new node of 2. Same thing for the right, and I'll have 8, and then
Okay, this is gonna take a while, I guess, to create. Is there default arguments that you can pass in the constructor for node? It's probably simpler if you have these passes. I'm not too sure about Java, but if you had node left and then node right?
yeah.
Just to make it faster to create these.
Yeah. So
then we could set, this dot node left and this dot node right.
This dot right is equal to right. But I don't know if that's gonna like increase, make it too much easier. Here I'm gonna actually have to name this like node left. You know what I mean? Like
Oh, yeah, okay, yeah, it actually does make it.
It's gonna be a little even worse.
I mean, you still have to create that node for 2, right? Because then you have to assign its left and right. Unless you just did root dot left dot left. Okay, got it. Yeah, sure. Yeah. If that works quicker, then.
It's gonna be a little quicker. So if I do left dot left and then
right, yeah.
0, and then for the same, I'll just do 8 is equal to 4, and then right dot left is equal to 3, and right is equal to 5, and the only thing that's left is this thing is like there's a left 7, right is 9, and then all I have to do is call CA of root, and so at first it was this, so we'll check that first, and then so yeah, so let's see if that works. Okay.
Oh, I think it's just right.
Yeah. Well, current is not null. And then there. Yeah, I just need to do this. There. be 6. And then what I can do is, so let's check the 7 and 9. Oops, this should be it.
Wasn't that the same tree we just had? On line 43 and 44. Sorry, I didn't see the change. Weren't those just 7 and 9 right before?
7 and 9. Wait, can you say that again?
On line 43 and 44. I don't know if you just changed that. Were those just 7 and 9?
Oh yeah. I changed it was like left and left here. I just changed it to left and right. So like it was overriding.
Okay, got it. Yeah. Which I guess in right, the first test case it didn't matter.
Yeah, it didn't matter because it didn't
Gotcha.
reach those.
Yeah.
So let me just run it at 7 and 9 for that.
Yeah, I think it would still end up being 6.
Well, I think it's just running. It's not installed. Does it mean that it's an infinite loop? I think so. So what's happening is, let's see, if p.val is greater than current.val, then p direction is equal to current.right, else p direction is equal to current.left, and the same thing for that. And if p dir is not equal to q dir, return current. Weird. So let me see. So what it's gonna do is like 6, right? Then p that value is greater than current value and q that value is greater. So they're gonna both point to 8. So in that case, this is not gonna hit. So it's actually gonna go again, then again. Oh, oops, I know why. It's because we actually need to else.
Right, so maybe we can look at some of the initial if-else's you had as well, right? I guess this would, because it's always going to be p-dir, like will line 68 always give us a solution?
Well, 68 is just like when they're actually the same. I just like change the current to go, because like the both directions are the same. That means what's it called? Go down the path because they're the same. So I just forgot about that. That's why it was an infinite loop, because I wasn't changing the current.
Right. So this might, this might fix the actual case for the other conditions as well. Let's I guess try some more test cases.
Okay, sure. So 7 and 9 worked. Then let's do maybe what else? 4 and 7. So I should give 6, and then 5, maybe 5 and 0, 0 and 5 should give me 2. Yeah.
Okay.
Maybe what else?
I mean, these are a lot of the times the exact same case, right? For
Yeah,
the most part. So maybe we could try something where, say, both the elements are the same thing.
Right? Okay.
It's probably helpful. And then, other variations of that, right?
Yeah, sure. So if they are both the same, I do get a null pointer exception, which I think makes it like if it's root.right, so it's both 8. That means that so if I go, so 8 is going to be the same, and I go down the same path, so it's going to both are going to equal to 8. Yeah, I see. So that means that I need to change the if statements, I think. So if it is equal, greater or equal current value. So at any point, if I've or like I see. So okay. So if it's, let's say even if it's like 8 and 7, 8 and 7 would actually have to return 8
Okay.
because yeah. So so that's, I guess, like the case that you gave me is like it's going to be a number of where it's either going to be the same or one of them is going to be the ancestor of the other.
Right. Where
So
it
those
turns
are
out
going to,
that that node, is the LCA, right?
yeah. So I think that's, yeah, and the case that I didn't see. So that means that, so if it is like that, though, so at any point I actually, while I'm going down the path, my path, if I encounter that any of them is actually equal, then I return that value right away too.
Right.
Because the other value has to be below that. I mean, in the subtree of that value in either side. So yeah, so that means that if it's equal, or else if, so I just have to like kind of make 3 things here. Else if it's right, else it's gonna be equal. That means I just return right. Can't notice that there's a lot of overlap kind of in these cases, but I don't know if I can actually unify them. I could. Yeah, it's fine.
What it's really, I guess, saying is, if it's equal to P or Q, right?
Yeah,
Yeah, even separate, I guess it's.
I think in that case this should give, yeah, 8. So it does give
Okay.
8. So let's try that case where it's actually 8 and 7 or something. 8 and 7. So that means that should
So just
still
8.
8. Yeah. So that's another, I think, edge case that is working now. Another is if it's null, they're both null, I think my program is gonna, let's say, I give it null and null.
Right. Well, I think we can just assume that they are valid nodes inside of the tree. So both P and Q will be non-null.
Okay.
If it turns out that the root is, it does exist as a tree. So there's the case that you might be given an empty tree, but if you were given a non-empty tree, you can assume that the nodes are valid.
Okay. So if it, so you said it's possible that the root could have null. It could be null.
Yeah.
And then, okay, in that case, I will not go into the while loop and I will just return null. Yeah. So that should be fine. So that case is good too. Let's just try it. Actually, no. Let's.
It's
So
only because
node.
during the creation. Never mind.
Wait. So current is going to be equal to root, and then current is equal to null. So it
It's just
shouldn't
because
go.
you're printing the value, right? The code is still returning null, but it's on line 48. You're trying to get the val out of null.
Yeah, makes sense. Makes sense. In that case, I cannot see the val. Well, it depends. So the function should return the node, right? Not the value. In that case, it should be fine. It works. Okay. So that works. That means another case is when they're both the root, which should be the same case as them both being 8. So that I think should be fine. Yeah, it seems like it's fine. Can't really think of anything else at the moment.
Okay.
Yeah. So both roots either so when they diverge, it works when it's the same and when one is the ancestor of the other. What else is there? What else could it be? Let me see. Another. So if we have 5 here, then the other. Yeah, I can't think of anything else. Really.
Okay, so I guess you're saying that's your final solution?
Yeah.
All right, sounds good. Yeah, I guess for the time, I'm okay with doing another question. Did you want to go through one?
Yeah, sure. That sounds good to me.